Hey yo guys, you're on Quadratic Functions revision course and this is everything you need to know. So here is more examples and that's why this is going to be much shorter than the previous one. Previous one actually was more analytical, more for those who are homeschool person, like they do their education at home. So please make sure you understand that. That's why it's pretty lengthy, but however deep for a complete understanding how to cope with standard form and how from standard form find all critical points like intercepts, Y and X intercepts, vertex point, and how to finally to sketch it. Also there you can figure out how to solve which method we used in order to solve quadratic equations. So I showed several ways, so make sure you watch that. And today we're gonna go through more examples. That's for those who already got the main idea how it works. And now let's get started. So grab your pen, grab your notes, and here we go. We're going to consider three examples. That's the first one, this is the second one, and the last one's third. So they're all pretty different. So that's why I think we consider how they actually, what's the difference in between them. Okay, so let's get started. What we're gonna do, we need to sketch the graph of the following function by considering the value of a leading coefficient. Next, we need to consider y and x intercepts and also the vertex. So actually, we need to reflect all critical points that are very significant in sketching the graph. Okay, let's get started from that one. And first, what we're gonna do, we need to consider the value of a. Just remember the general form, x squared plus bx and plus c, where here leading coefficient a is equal to 1, so we're analyzing a is more than 0, so that's why branches up. That's what we can conclude from there. Let's go straight to the next one. So 2x squared plus 5x minus 3, in this case coefficient is 2, is also more than 0, so that's why the first point branches up. And let's consider the last one. Here, be careful, we need to expand the brackets. Finally, we'll get negative 0.5x squared. That's what we need until now. And we understand that the leading coefficient is negative 0.5. So it's negative, so branches down, okay? So the first item done everywhere, okay? Let's move next. We need to find y-intercept. So when we're looking for y-intercept, we're just simply saying that in this case, x coordinate is going to be 0 because your parabola goes through y-axis where exactly as x is 0. So that's why we're just saying that x is 0 and we have y equals negative 1. So this is y-intercept in that case. So we just fix this point right here. That's already enough. So this is negative 1 and this is y-intercept. So I just prolong the x-axis down, okay? And simply we know that this is the point that where the parabola crosses their y-axis. Okay, so let's go next. And the next stop is here. We need to find y-intercept. In our case, we're also saying that x is 0, and this is the free coefficient c, right? So this c signifies the y-intercept, so y-intercept is negative 3. Okay, so we again fixed it up here, and I just pull on this, vertical axis just down, okay, and we fixed y equals negative 3. It's right there, so negative 3, and this is y-intercept. Okay, and we move next. Here we need to obviously expand the brackets, and by expanding we can say what the free coefficient. However, I do a little shortcut. To expand the brackets, I don't need the full expression, so I just simply know that when we multiply negative 2 by negative 4, I'll get 8. So 8 is here. And on top of that, I apply as the factor negative 0.5. So I'm multiplying, and I can write negative 1 over 2 times 8, which will give me negative 4 in the end. So negative 4 is going to be y-intercept, and 1, 2, 3, 4. We fix that negative 4 as the y-intercept, and that's why here is negative 4. And actually you can expand in full. I can do it very quick. So x squared minus 6x and minus 2 by minus 4 will get plus 8. However, if we apply negative 0.5 as the common factor, we'll get negative x squared over 2, I just convert it into fraction, plus 1 over 2 negative by negative 6, you'll get x over, 3x. And finally, what we got is negative 4. This is the y-intercept. So that's the y-intercept right there. Okay, so we fixed y-intercept everywhere, and in the very first one as well. So y negative 1. And now we need to find x-intercepts. All right, let's go and find x-intercepts. How to do this? The best way is to say that y is 0, and we need just to solve the equation x squared minus 1 equals 0. So the fast track is to transfer 1 here and say that x is simply plus minus 1 because we're taking the square root later on. Or there is another way how we can do. That's the first way. And another way we can factorize in this manner. We split on factors and equate each factor to 0. So that's why x1 is 1 and x2, the second bracket, there is also possible to be 0. So that's why negative 1. All right, so now we are going to prolong this axis here because we have negative 1 and 1. So that's why those are x-intercepts. So that's why we mark them as the red one. Okay, so we've done this here, and we go to the next equation. We do the same, so we equate y to 0, and here we need to solve that quadratic equation, 5x and finally minus 3. So we equate to 0. Here's I want to use the formula instead of factorizing, and I would use quadratic formula because what I'm going to do, I just write the pattern for factorized version of our quadratic expression. So x1, x2 solutions using quadratic formula. So how would I find x1 and 2? I just use quadratic formula, right? Here's the quick reminder. Discriminant over 2a, where discriminant is simply discriminant here, d, which stays under the square root, is simply b squared minus 4ac. Okay, so let's calculate together. So let's do x1, x2. It's minus b, so b is 5, so minus 5 plus minus square root of 25. Calculate discriminant. So 25 minus 4ac, so that's why it's positive 12, and times 2 it's 24. So over 2a over 4. So x1, so I can even simplify further, so it's going to be negative 5. Here is going to be 25 and 24, 49, so we'll get square root of 49 is 7 and over 4. So the first solution is negative 5, negative 7, it's negative 12, over 4 is negative 3. So that's one x-intercept, and another x-intercept when we take in plus, so minus 5 plus 7 is 2, 2 over 4 is 1 over 2. So we've got two solutions, and that's why I again prolong this line here. We've got negative 3. So negative 3, that's one x-intercept, and another one is 1 over 2, is right there. So this is another one. 1 over 2, and 3 right here. Okay, so I mark them as red one again, those x-intercepts. And let's go to the last one. So last one is already factorized, and this is the key advantages for factorized form. From here, you already can equate y equals 0. So final will give us that x minus 2 is 0, so that means x1 is 2. And the second x-intercept is x2 equals 4. So we've got 2 and 4. So 2 right here. That's 1. And 3 and 4. This is 4. And we've got both x-intercept immediately. All right. So we've done everything. So that's x-intercept here. Let's go back. Here is x-intercept. We found -3 and 1 over 2. So I just fixed that. So x1. No, I'm not going to write because that's going to be parabola. Okay, so I write it here. So x1 is -3 and x2 is 1 over 2. Okay, so we found also x-intercept everywhere. So we know the branch is up. We know that we have like this sort of structure, but we need to find the vertex of the parabola, and also we need to find the line of symmetry because it should go through the vertex. Okay, so, and let's go back here as well. So we found x-intercept, right? That, and we start from the vertex. Let's explore the vertex. The vertex can be figured out, that's x vertex, like using the formula minus b over 2a. In our case, b is 0, so that's why x vertex is simply 0. Here's another approach. If you consider the vertex form of the parabola, so I just mentioned that, but here we are going to consider next time, so the vertex form for explanation. So the general vertex form is x minus h squared and plus k, where h and k are vertex coordinates. So that's why we just simply say that the vertex will have the coordinates h and k. In our case, h is 0 and k is -1. However, we found in the same manner x vertex as 0, so this is correct. And how to find y vertex? Remember, we need to plug x vertex equals 0 instead of x, instead of argument, so that's why we'll get -1. So finally, we found the vertex of the parabola, so we can fix the coordinates 0 and -1. So here, this is the vertex as well. So this is simultaneously the vertex and also y-intercept. So everything is done to draw parabola, but I would like to put the line, which is simply, oops, I'm not going to use that, better to use this one. So I mark as green, and yeah, and I'm saying that this y-axis is going to be the vertex. Oh, actually bad color, sorry, I just fixed it up. Let's put the red one, is okay. So the red one is going to be the vertex, the line of the symmetry that goes through the vertex. Okay, so we've got everything, and now we can draw the parabola. I use the blue one, yeah, or purple. So it goes through that point and symmetrically with the branches up. So that's your parabola with the equation y equals x squared minus 1. So that is done and it's finished. Okay, let's move to the next. Here we need to find the vertex, and which way we can do? We can use the formula minus b over 2a. So in our case, minus 5 over 4, that's the x vertex. Okay, so if we plug that instead of y, we can figure out their y vertex coordinates. So let's plug it and let's calculate. So 25 over 16 times 2 is going to be 25 over 8. Okay, next, plus 5 times negative 5 over 4 is going to be negative 25 over, my bad. The first one, 25 over 16. Oh yeah, over 8. That's okay. That's okay. And then we plug in negative 25 over 4. So we'll plug in that and we'll get 25 negative sign over 4. Next one, we subtract 3. That's what we have, but instead of like doing, calculation as the fraction, I simply put into calculator all that and calculate it once. So minus 3. So what I've got, that the vertex in this case, y vertex, is around negative 6.1 to 1 decimal place, or around negative 6. So that's why vertex coordinates are negative 5 over 4. So 5 over 4 I also can convert as 125 and negative 6.1 to 1 decimal place. So that's the vertex. And if I drop this coordinates here on Cartesian plane, it's everything done to set up the vertex and plot the parabola or sketch the graph. So 125 stays for x, 125, and negative 6.1. So negative 6.1 is somewhere around here. So that's why. So this is going to be maybe just what we can do if I switch that. I'm not sure. Let me see. Can I? Sorry, not. Okay, anyway, so 125, that's the vertex. However, it's weird, yes? Okay. 125. Negative 125, yeah. So we didn't put the negative sign. Yeah. It's going to be negative 125 because this, I just forgot to put the minus. So because I see that something wrong. So negative 125 somewhere here and the bottom side. So approximately your vertex is going to be somewhere here. Okay? Somewhere here. That's your vertex. And that's why the line of symmetry should go through that point, just going vertically. This is the line of symmetry. By the way, I can fix the equation of that line as x equals negative 5 over 4. This is the line of symmetry, and around this line I just use the graph, symmetrical graph around this vertical axis. And finally we move next, okay, to the final one. Here we need to use factorized equation for the graph. And right now we're going to do the same steps. So vertex, x vertex coordinates is negative b over 2a. So in our case, a, be careful, is negative 1 over 2. And b is 3. So that's why if we plug those coordinates, we'll get simply 3 over negative 1 over 2, which means 2 goes on top. So if you divide by negative 1 over 2 and times 2, so actually 2 and 2 will be cancelled and you'll get just positive 3. So x vertex is positive 3. Next one, y vertex, we simply need to put in, and I'll put here because in that expression much easier to put, and use calculator we can calculate. So 0.5 times brackets, not brackets, but 3 minus 2 is 1, and 3 minus 4 is negative 1. So we've got 0.5 finally. So you can check using calculator. So we'll just plug y equals 3. X equals 3. And that's why we'll get 0.5 finally. So the vertex coordinates are 3 and 0.5. And finally, we can fix it here. So actually, as it occurred to be, the line of symmetry should go through 3 and 0.5. So 3 and 0.5 is negative 1. the x equals 3, because by definition this point should be as the midpoint of 2 and 4. We can check this. And also we need to fix the vertex y coordinate, which is 0.5. So it's going to be somewhere here. So that's the vertex. And now we can put the parabola symmetrically. So this graph, maybe let's take dark blue. This graph should look like this. Let me sketch more appropriate. So this is left-hand side branch, and this is the right-hand side branch, and everything in accordance with what we analyzed in the previous video in details, and here we just realized on the practice. All right, so all three at once in a parallel way. So we fixed all critical coordinates and finally solved that. So hope you like that. I'm pretty sure that was pretty well explained. So guys, try to do it by your own, more practicing, of course, that will be really fruitful for you. And don't forget to visit this page in this channel for Resilience A-level class if you're interested in A-level math. And don't forget to check my video about mechanics, so where I explain 2 problems dedicated to motion. Actually, I want to fulfill the collection with more videos dedicated to mechanics. So check it out and be in touch. That was Daniel Dallas. Peace out.